Good day, madam. My name is Leong Pei Sin and my metric number is CD200193. The mechanical part that I'm chosen for me to do the calculus individual assignment is coupling shaft. Later on, I will show you how the process of I'm doing the coupling shaft using the plasticine and how I value it using the multiple integral formula. The finding of area and volume. In this individual assignment, we are required to use multiple integral to find the area and volume, which is double integral and triple integral. The mechanical part that I chosen to do this individual calculus assignment is coupling shaft. This is the model of my part of doing the coupling shaft. In my coupling shaft, there are three different types of shape, which is cylinder, sphere, and elope. The first shape is the cylinder shape. You can see as the picture below. Towards this picture, I calculate that the height of the cylinder is 6 cm, while the radius of the cylinder is 4 cm. The 6 cm locate of the height is the z value, which is the upper limit, and the lower limit is 0. While the radius, since the diameter is 4 cm, so the radius we needed to divide by 2 is equal to 2. So the radius of the upper limit is square root of 2, while the lower limit is 0. And here we can conclude that x squared plus y squared equal to our height z equal to 6. The area that I use to find the cylinder area is polar coordination, which is RD delta. And I use what I have learned in class to do this calculation. As the same as the volume, while the volume I'm using the cylindrical coordinate, which is dz RD delta to find the volume. At last, I will conclude that the area of the cylinder and the volume of the cylinder is the value is the same, which is 18 pi. The next shape that include in my coupling shaft is the elope. The elope area, the diameter of the elope area is 15 cm, which I divide by 2, become the radius is 7.5. At here, we can conclude that the upper limit is square root 7.5, while the lower limit is 0, same to the height, which is 1 cm. In this elope area, I also using the polar coordination to find the area, while the volume, I am still using the cylindrical coordination to find the volume. You can see the calculation as below. The third shape is the sphere area, which located below the coupling area. It has 6 sphere shape. The sphere have a diameter of 3.2 cm. C is located at XYZ plane, so the formula is x squared plus y squared plus z squared equal to 1.6. The area, the formula that I'm using to find the area is RD delta, which polar coordination, while the volume I'm still using the cylindrical coordination, which is dz RD delta. The upper limit of z, which is square root of 1.6 minus x squared minus y squared. And the radius value is square root of 1.6. The lower limit is 0, while the delta is 2 pi and the lower limit is 0. The last shape that contained in my coupling shaft is also the sphere shape, which is located above the cylinder. The diameter that I calculate the sphere shape is 2.4. and divided by 2, it becomes the radius, which is 1.2. I'm still using the polar coordination to find the area, and the volume I'm still using the cylindrical coordination to find the volume. And below is the calculation. The upper limit of my radius is square root of 1.2, while the lower limit is 0, while the pi is 2 pi upper limit and 0 is the lower limit. Same as the volume. And lastly, I can conclude that the area of each shape and the area and the volume of each shape is, lastly, the calculation is still the same. After I calculate the area and volume for all the surface, I will total up the total area and total volume. And lastly, we can conclude that the area and the volume will still get the same answer, which the last final area and volume is equal to the same, which is 39.32 pi cm square and cm cube. That's all from me. Thank you.